Okay, this is homework help for Unit 5, Worksheet 9, Math 3, and I'm going to start with question number 3. So for question number 3, they want us to solve algebraically for x. So the first thing I always want to do is isolate the radical. So there's nothing in front of or behind the radical, so the radical is already isolated. And then the second thing I want to do is I want to square both sides. So I'm going to quantity square both sides. And then when I do that, the squared and the root are going to cancel. So these will cancel, leaving just the x plus 3. And then here, when I square 2x, so that's going to be the same as 2x times 2x. So that means I need to square the 2 x multiplying it by itself. So then 2x times 2x is just 4x squared. And then once I do that, I have a squared term, so that means I want to isolate or equal it to 0. So because I have a squared term, I want to equal it to 0. And I want to keep the 4x squared positive, so I'm actually going to subtract the x and subtract the 3. So I'm going to subtract x and 3 from both sides. And then my goal with that is trying to keep my squared term positive. And so then x minus x is 0, 3 minus 3 is 0. And then I'm not actually combining anything here. I'm just going to put it in descending order. So 4x squared minus x minus 3. And then once I get to here, I want to factor. And so I want to list my possible factors here. So for 4x squared, it's either 4x and 1x or 2x and 2x. And then for 3, my only choices are 1 and 3, but one of them having to be negative. So I'm trying to figure out, how do I multiply 4x and x with 1 and 3 to get negative 1x, or how do I multiply 2x and 2x with 1 and 3 to get negative 1x? So if I look here, this will give me 4x times 1 and 3 times x. So 4x and 3x when combined can somehow give me a 1. So I know I'm going to be working with 4x and x. And so I want to multiply the 4x with a 1. So the only way to multiply the 4x with the 1 is if they are not in the same parentheses. So I mean, so 4x needs to multiply to the 1, and then the x needs to multiply to the 3. And I want to get a negative 1x here. So that means I want my 4x to be negative and my 3x to be positive. So just to check it real quick, when I multiply these two together, that gives me positive 3x, and when I multiply these two together, it gives me negative 4x. And when I combine that, 3x minus 4x is a negative 1x, so then I know that's the right factor. So then once I do that, I'm not finished. I still have to solve. So then I'm going to set each one of these equal to 0, and I'm going to do that up here just because I'm running out of room. So I'm just going to rewrite this. So this is 4x plus 3, and then x minus 1 equal to 0. So I didn't do anything other than rewrite that same equation up here, and that's just to give me a little bit of room to work. And so now I'm using the zero product property, so I'm going to set each factor equal to 0 and then solve. So my first factor is 4x plus 3. I want to equal that to 0. And then x minus 1 equal to 0. So I'm going to add 1 over to the other side, so I get x equals 1. And then on this one, I'm going to subtract 3 to both sides. And then divide by 4. So then I want to see which one of these is the extraneous solution, and the one that's extraneous is the one that would give me, right before I square it, which one would give me a negative value, right? So if I were to replace x with 1, 2 times 1 is positive, so that one's a good solution. But here when I replace x with negative 3/4, I'm going to get 2 times a negative number, which is negative. So that means x cannot equal negative 3/4, right? That's extraneous. And so then my true answer is just x is equal to 1, right? So now for part B, it says to rewrite the algebraic equation into a system of equations and accurately graph. So to do that, what I want to do is I want to look at my original equation. So I have the left side, I'm going to make f of x. So my left side is f of x equals the square root of x plus 3. And then my right side, I'm going to let that equal g of x, which is going to be 2x. So all I did was take that and let my left side equal f of x and my right side equal g of x. And then I want to graph both of these. So for my start on this one, I'm looking to see what am I doing to the x. I'm adding 3, so my h will be negative 3. And I'm not adding anything to my y value, right? F of x is the same as y, and then I'm not moving anything over because there's nothing on the outside, so that would be 0. So my start is negative 3 and 0. And then my stretch is going to be what I'm multiplying by, which is positive 1. Oops, started right, negative 1. Okay. Let's go ahead and graph this. So my start is at negative 3, 0. And then my stretch is 1, so up 1 over 1. Okay. And then I want to make sure I have a little bit more accurate graph. So I'm going to go ahead and let x equal 1 also. So if x were 1, then that would be the square root of 1 plus 3, and 1 plus 3 is 4, so the square root of 4 is 2. And then now I'm going to go ahead and connect, and then that gives me that graph there. And then I'm going to do the same thing for g of x. So my start is going to be 0, 0, because I'm not adding anything to x and I'm not adding anything to 2x, right? So there's nothing outside of here, nothing grouped with parentheses, so my start would be 0, 0. And then my stretch or my slope would be what I'm multiplying x by, which is 2. And so for this graph here, my start is at 0, 0. And my stretch is 2, so I'm going to go up 2 over 1. And then I'm also going to go down 2 over 1, because this is linear, because I'm not squaring anything and I have no square root. So then I'm going to connect those dots. And so f of x is equal to g of x, where the two graphs intersect, and they intersected here, which was at x equals 1. All right, and then on the back side, let's take a look at question number 15. So the directions say to solve for the following for x and check for extraneous solutions. So I want to isolate the radical, which it already is, right? Nothing on the outside at all. So once the radical is isolated, I want to quantity square both sides. So on the left side, the root and the square are going to cancel each other out, leaving me with just x minus 2. And then on this side here, I want to write this twice, because squared means I have 2 of them and there's no root to cancel. And then I want to distribute, right? I want to distribute to get rid of my parentheses. So I'm going to distribute the 4 into both of those terms. So 4 times 4, 4 times negative x. And then I want to distribute the negative x into both of those. So negative x times 4, and then negative x times negative x. And then I can combine these two together, so I'm going to do that. So negative 4x and negative 4x is a negative 8x. And then because I have a squared term, I want to use a zero product property, so I need it to equal 0. And I'm going to leave the x squared here, right? I want to keep that positive. So I'm going to subtract the x and add the 2. So I want to subtract x and add 2, subtract x from the negative 8x, and then when I add the 2, I'm going to add it to the 16. Right, because I want to make sure I'm adding it to things that it will combine with. And then all of that is 0. And then I have 16 plus 2, and negative 8x and negative 1x is negative 9x, and then a positive x squared. And so that's in kind of a weird order, so I'm going to put that in the correct order, right? Because our squared term should be first. So this is a positive x squared, and then the negative 9x, and then the positive 18. Okay, and then I want to factor it. So I'm going to go ahead and just kind of do that out loud. But in general, x squared can only be x times x. And then my factors of 18 are 1 and 18, which won't give me a 9. 2 times 9, which won't give me 9. 3 times 6, which will. And so I want to use 3 and 6. So 3 times 6 is 18, but I want it to be a negative 9, so these both have to be negative. So negative 3 times negative 6 is positive 18, and negative 3 plus, or negative 3x plus negative 6x is negative 9x. And then I want to use the zero product property. So I'm going to carry that over to here. So I'm going to set each of these factors equal to 0. And then solve. So I'm going to add 3 over. So x equals positive 3. And then I'm going to add 6 over to the other side. So x equals positive 6. So now I want to check for extraneous solutions. I'm going to go back to the point of where I squared, which was at the very beginning. And I want to make sure that my square root does not equal a negative number. So if x were 3, 4 minus 3 is positive 1, so that's okay. If x were 6, 4 minus 6 is negative 2, and a square root cannot equal a negative, so then this one is my extraneous solution, so x cannot equal 6. So x equals 3 is my actual value. Okay. And then one more here, let's take a look at question number 19. So same idea, I want to make sure the square root is isolated, which it is, and so then I'm going to square both sides. So the square root and the square cancel, leaving me with just x plus 7. And then over here, because I'm squaring and I don't have something to cancel that square, I have to write it twice. And then I want to distribute. So x times x is x squared. X times negative 5 is negative 5x. And then negative 5 times both of these, so that would be negative 5x. And then a negative times a negative is a positive, and 5 times 5 is 25. Combine like terms, so I can add these two together. So that would be negative 10x, and then I still have the positive 25. And then before I factor, I want to make sure it's equal to 0, so I need to get rid of the x and the 7. So I'm going to subtract x and subtract 7. So then this would cancel to 0, and then I have x squared, and negative 10x and negative 1x is negative 11x, and then 25 minus 7 is 18. And then I want to do my factors of 18. So again, I'm just going to do this in my head, but 1 times 18 won't give me 11, right? 1 times 18 gives me 18, but won't add up to 11. And then 2 times 9 is 18, and also 2 and 9 will give me 11 when combined. But I want them to both be negative. So negative 2 times negative 9 is positive 18, and negative 2x and negative 9x is negative 11x. And then for the zero product property, I'm going to set each of these equal to 0. And then solve. So I'm going to add 2 to the other side, so x equals 2. And then add 9 over, so then x equals 9. And then I want to check for extraneous, so I go to the point of where I squared, which is right here. And I know a square root cannot equal a negative. So if x were 2, 2 minus 5 is negative 3, and a square root cannot equal negative 3. So this is my extraneous. If x were equal to 9, I have 9 minus 5, which is 4, and the square root can equal positive 4. So then this is my final solution there. Okay, and then that's it for this worksheet.